Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Double Dealing by Full Deck and Missing a Few Cards. And here are the rules. We have Sudoku, X sums, and cages. Where we have standard Sudoku rules apply, where the digits 1 through 9 appear in every row, column, and box. We also have X sums, where digits outside the grid give the total of the first X digits in the row or column starting next to the number outside the grid, where X is the first digit along that row or column. So, for example, if this were, say, a 4, that would mean the 13 is the sum of the first 4 digits in that column here. If this were 3, that would mean 13 is the sum of the first 3 digits in that column. So this would have to be 3, 4, and or not have to be. 3, 4, and 6 could be a perfectly fine example to satisfy this X sum rule. And then also we have cages, where digits in cages sum to the value shown in the upper left corner of the cage. So for example, these 3 digits add up to 13, these 2 add up to 10, these 2 add up to 13, etc., etc. So for example, if this were, say, a 4, this would have to be a 6, because those 2 digits must add up to 10. And finally, for more of our puzzles, or missing decks, full deck, and missing a few cards puzzles, please visit missingdeck.net. So if you enjoy this puzzle and you want to do more puzzles similar to them, go visit visit their website, I guess. And anyways, with all those rules, I'm gonna be posting a link in the description if you want to play along. And now I'm gonna get started. Let's learn how to Sudoku. Okay, so best place for me is I would start with the X sums clues. Now, each X sums clue, first of all, you can never have, unless the sum is 1, you can never have the first X digit, essentially, being 1. Right? Because that means you only have 1 digit to add up, and it can only be 1. So this always has to be at least 2. To get add up to 10 or 13, the only amounts you can have are 2, 3, and 4 adding up to those, right? 4 can be 4, 3, 2, 1 adding up to 10. And if you try to have 5 to add up to 13, that doesn't work, because the minimum for 5 unique digits is 5, 4, 3, 2, 1, which is 15. So these all have to be 2, 3, and 4 as the X, or the X sum clues, right? Well, we have a 2, 3, 4. This can never be 4, because if this is 4, we know these 2 digits by themselves add up to 10. And then 4 would have to add up all 4 of these digits. So it would be 10 plus 4 at least, which is 14, which breaks the X sums rule. So this must be 2 or 3 here. What else do we have? One of these, though, is a 4. It's probably the 13, but we don't know that for certain. If this is 2, to add up to 10, it has to be 2 and 8. If it's 3 digits adding up to 10, it could be 3, 1, 6, or 3, 2, 5. And this would be 5, and this would be 2 in that scenario. So this has to be 1, 5, 6, or 8, guaranteed. We don't know what it is, though. If this were 4 digits adding up to 10, this would be 4, 3, 2, and 1. that would eliminate all possibilities for that cell there then. So this cannot be 4. Therefore, this must be a 4 because of the 2, 3, 2, 3 pair in the column. Therefore, these 4 digits add up to 13. And again, this must be 2 or 3. This can't be, well, this could be 4 here, actually. So if this is 4 digits adding up to 10, you have the same problem as this one adding to 10, right? Because that would include these 2 digits. They already add up to 10 here, so this would add up to 14 if that were the case. So this cannot be 4 here. This could be 4. Actually, this cannot be 4 for the same reasoning. If this were 4, this would add up to 10 by these 2. So that would be 13. Sorry, this would be 10, and this would be 4, which would all be 14. And therefore, 3 digits would already add up to 14. And so 4 digits could never add up to 13. So this must be 2 or 3. If this were 2, 2 doesn't add up. So 2 can never be the digit next to the 13, right? If it were, what digits add up? What 2 digits, including a 2, add up to 13? It would have to be 2 and 11, and 11 is not a digit. So this cannot be 2. This has to be 3, which forces this to be 2. These 2 digits add up to 10, so it's either 1, 9 or 4, 6 here. This 3 means this can't be 3, this must be 2, which makes this 2 and 8 adding up to 10. This can never be 2 and 8 adding up to 10 because we already have an 8 in the column. So this must be 3 or 4, which forces this to be 2, which makes this an 8 to add up to 10. That means this is 2. This can no longer be 2 here. This is 3. This 2 and 8 add up to 10. This must be 2, 3, and 5 adding up to 10 here because this is 3 digits. This is 3 digits adding up to 13. This adds up to 10. This adds up to 10. This is 3. What does that leave? That means this is 13. This is 13. That's 26. Plus 10 is 36. 45 minus 36, and 45 is the sum of all the digits in a row. So that'd be 1 through 9. 45 minus 36 is 9. So this is 9, which means this can't be 1 or 9. This is a 4, 6 pair, which leaves this as 1, 5, and 7 remaining. Okay. Therefore, these first 3 digits add up to 13. These 2 digits add up to 10. These 4 must add up to 13. So the remaining 3 digits add up to 9. It's either 1, 2, 6, or what else can it be? 1, 3, 5. Those are the only possibilities. And this can't be 1, 2, or 3 here. So this must be 5 or 6 here, which means this is 7 or 8 next to it. This can't be 8 because of the 8 in the row, so this must be 7, and this is 6 adding up to 13. Therefore, this is 4 and 6. This must be 1 and 2, and 2 cannot be here, so 2 must be here, and this must be 1. This can no longer be 1. This can no longer be 7. We have 4, 2, 6, and 1 already adding up to 13. If this is 4, what does the rest have to add up to? 9, and we already have a 7 here. So it can't be 1, 1, 7 because that would be a repeat in the same column. So this can't be 4, this must be 3. 3, 5, and 5 would add up to 13, but that's not possible. So this has to be 3, 1, and 9, adding up to 13. This can't be 1. This can't be 4 and 9, adding up to 13 for these 2 digits. This can't be, so this is 5 and 8, or 6 and 7. This can't be 5 or 7 because of the 5, 7 pair in the box, so this can't be 6 or 8 here. This can't be 2, 8, or 3, 7 adding up to 10, so this is 1, 9, or 4, 6. 1 and 9 cannot be here because of the 1 in the box and the 9 in the column, so this must be 4 and 6 and 4 and 6. That means 4 and 6 cannot be the pair adding up to 10 here, because neither of these could be 4 or 6. This can't be 2 or 8 either. If it's 1 and 9, this is 1, and this has to be 9. If this is 3 and 7, this has to be 7, and this is 3, but 7 can't be here because of the 5, 7 pair. Therefore, this is 1, and this is 9. That leaves in row 4, the remaining digits are 1, 3, and 5. So this is 1, 3, and 5. This is 1, 3, and 5, but this can't be 1 because of this one. This can't be 5 because of the 5 here. This can't be 3 because of the 3 here. This is 1. This is 1. Do we have anything else? 2 cannot be here, so 2 has to be one of these 2 digits here, which means 2 cannot be here or here, so this must be a 2. In box 9, the 2 can't be here, 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 or here, so it must be here. In box 5, it has to be one of those 2. 1 has to be one of these 1s remaining. Remaining digits in column 3 are 4, 5, and 8. 5 cannot appear here or here, so this must be 5, which makes this a 4, 8 pair here. This 3, 4 pair in row 9 eliminates 3 and 4 in the rest of the row, so this is 8. This has to be 4. Where else did we target now? Maybe this or this. If it's 4, it would have to be 4 with 1, 2, and 3, but we already have a 2 in the column, so this can't be 4. This must be 3, this must be 4. The 3 has to have 3 digits adding up to 10, so these 2 digits must add up to 7. The only 2 digits remaining can't be 2, 5, can't be 3, 4, it's 1, 6. So this is a 1, 6 pair, which eliminates 1 and 6 in the rest of the column. This can't be 6, so this is 4, which makes this 6, which makes that 4, which makes that a 6. This can't be 6 anymore, so this is 8, which makes this a 5 to add up to 13. These 3 digits must add up to 9, because 13 minus 4 is 9, and these 3 digits must add up to the rest. Well, you can't have a 6 here, so it must be 1, 3, and 5. So this can't be 2. So this must be a 1, 3, 5 triplet. This can't be 1 because of this one. Whereas a 2 now in row 6, it has to be here. This 1, 3, 5 pair, this 2 eliminates 2 here. So this is 2. That leaves this digit as a 7. We have in box 5 a 3, 5 pair that eliminates 3 and 5 in the rest of the box, so that means we have 4 and 8 remaining. This can't be 4 because of this 4, so this is 8, which makes that a 4. The remaining digits, this can't be 3 or 5 because of the 3 or 5 in the row, so this is 1, which means this can't be 1. This 1 eliminates 1 here, so this is 6 and 1 here. Now we're just doing Sudoku. Okay. This 5 eliminates 5 here, so this is 1, this is 3, this is 5, this is 3, this is 5. This 5 eliminates 5 here, so it's 7 and 5. What about the 1s? In the lower left box, we can't have a 1 here, we can't have a 1 here, so this must be a 1. Not for both, for this one. 1 could be either of these, so that's not... we have 9, 2, so those are already done. For 3s, in the upper central box, 3 cannot be here, so it must be 3 here. Therefore, and in the right center box, 3 cannot be here, here, or here because of the 3s in the row in the column, so this must be 3. We have 8 3s. We know where the last 3 has to be. It has to be here. 4s. In the upper central box, 4 cannot be here, so 4 has to be here. In the upper left box, 4 cannot be here or here, so 4 has to be here. That gives us 8, 4, so we know where the last 4 has to be. It has to be here. So now 5s. 5 in the upper left box cannot be here, here, or here, so it must be here. 5 in the lower right box can't be here, can't be here, can't be here, so it must be here because of the 5s in the columns and the rows. Therefore, we have 8 5s. We know where the last 5 has to be. It has to be here. 6s. In the right central box cannot be 6, can't be here, can't be here, and can't be here. So this must be 6. The remaining 6 in this upper central box is here. That leaves the 6 in this upper left box to be here. We know in the lower right box, the 6 cannot be here, then cannot be here, it must be here, which gives us 8 6s. We know where the last 6 has to be. It has to be here. The 7, it's the only digit left in the upper left box, so that's a 7. The only digit left in row 3, so that's a 7. In column 5, the only 7 left is here. In the lower right box, 7 cannot be here or here, so this must be 7 here. That eliminates 7 here and here, so this must be 7 here for the lower left box. We have 8 7s. We know where the last 7 is. It has to be here. 8s. 8 cannot be here in the left central box, so it has to be here. In row 9, it can only be here. We have 8 and 8s now. We know where the last 8 is. It has to be here. 9 in column 2, it has to be here. In column 1, it has to be here. In column 4, it has to be here. In row 8, it has to be here. In row 5, it has to be here. We have 8 and 9s now. We know where the last 9 has to be. It has to be here. And I think the rest are 1s. So this is a 1 and this is a 1 here. And that's how you solve it. Yeah, I mean, fairly straightforward. Really was the targeting the X sums. X sums were the limiting factor here, really. Well, I guess that with the cages, but yeah. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.